Hello everyone. Welcome back. Oh, welcome. This is actually the very first video. No, welcome back. And on this channel, so I thought we will start with a very simple introduction to that programming, of course. And we will look at everything from variables to OOP and abstract classes and everything, which I mean, on the top level, we're not going to go deep so that you can get with Flutter, and then from there we will keep going. So what you need to do is just go to that part .dev, where you can get a very simple interface where you can try out that code. So here we have an editor where we'll just write our code. You'll see the console. We'll write our when you run our code, this is where we're going to see the output and then a little bit of documentation on what we are writing. So we are going to start obviously with variables. So let's get started. Now what you need to know is that every that package or program, right, it has this function, right? This is a function, but we need it to be able to write to be able to run our code, because that starts running code from the main, right? It has to have this function and it has to be called main in your package or your file, whatever you want to call it. Actually, this is the starting point. So let's get started with variables. So when you want to have variables in that, you can easily just go with the var. And sorry, first time, that is actually a very strong typed language. That means whenever you're going to have an object, you have to give it a type, right, before you declare the object or instantiate it at the same line. You need to have the type. So we're going to start with the var type, which is let me just make a type. Right now I'll give the variable a name, and I'll call it I'll just call it my variable, my var, and then I'll just assign it to of course, if not hello world, what else, and which every that statement, actually you end it with a semicolon, right? Don't forget the semicolon. Okay, so this is how we get started. And my var is just a variable, which, as you can guess, is a string. If you know any programming, it is a string, but you give it a type of var, so internally that will just infer the type automatically, and that will know that this is a string. So I'll show you a function. It's called print, and then my var, which represents the variable, of course. Now the print just takes a string, and then it outputs that string to the console, which is what we want. And you can see hello world, right? So that is the var. It automatically allows that to infer the type of our variable, right? As you can see, it says string var on the documentation. Now apart from var, you can specifically say string. There is a string type in that. You can say string, and I'll just say name, and I'll give it a name of I'll just give it my name. And we have a string type, right, which is obviously just this. And sorry if I forgot to mention, a string, you can have double quotes or single quotes, right? You can have your strings any way you want them, with single or double quotes like this. So if I just say name, we will see that in the console. So apart from string, these are just the types that I'm showing you. And by the way, this is called variable initialization, right? Because we initialize it on the same line, we can just declare like this. Let's remove this. We can just declare the name, the name of the variable. In this case, it's called name, and then not actually assign it to any string object or any type of object. And then in somewhere else, we can just use that name and then assign it, right? And it's still going to be the same. So we have a string. This is actually how to use variables, right? You have to give the type and then the name, and that's just it actually with variables. And now let's look at something called dynamic. Right? There's a type called dynamic. The dynamic type, I'll just say something like weight. I'll just declare it, and then the dynamic type actually what it means is that actually let's give this a weight. When we give a weight of I will just use numbers, which is integers. In that there's a type called integers, and I would say maybe 65.5, or maybe let's just leave it at 65 for now. And the dynamic, what the dynamic type does is that when I hover over weight, when I click on weight, actually you will see that it's a type of integer, dynamic type, sorry. And right here, the dynamic allows us to do something like this. If you have guessed it before, weight is equal to, we can actually change it and put a string, for example, if you want to give it as a string. And we can actually do this because we declared it a type of dynamic. That means we can just change the type whenever we want on the fly, right? Down the road, we can just set it to another thing, another different type. So that is dynamic. And we need to see something called final. Now with final, I will actually just give a name. I'll say final, and then I'll say I will call this let's say age. And I can't actually do this because this is final, and we must initialize it where we declare it, right? With finals, you cannot just declare a final and leave it like that. You have to assign it to a value, because you don't change it. You don't change it down the road or anything like that, right? The final variable age must be initialized. So we can come and just initialize age with let's say 20 maybe, and it will work. And if we want still, we can still pass a type. I don't want to overwhelm you with all the types now because that will be next section, but we can put int, right, to indicate that this is a type of age. This is the int is the type, age is of type int, sorry. And with final, actually, if I do something like this, if I come to the age and then try to change it to maybe 20, 21 or anything else, we'll get an error because age can't be used as a setter because it's final. So just know that when you declare variables final, you cannot change them. And there's another type also which you cannot change, which is constant, right? It's spelled const, which is a compile time constant. It actually during your compile time in that, this is when it use this. This is when it creates this, when you compiling your that. So const I would say height. I'm just making this things up, and if I do this also, we will get an error because the const height must be initialized, line 11. So I'll just actually just comment this. You can press on control and then / on Windows to comment the line out. That means it won't run. It doesn't mean anything here, it's just a comment. And with height, as you can see, we have to actually initialize it also, just like final. So I can say 20 as well, and now the error is gone. And if I try to say height, is now 21, and as you can see it says error because a constant cannot be assigned to another value. You can't change it also, right? Const variables can't be assigned to a value because, well, you actually initialize them when you declare them. So that is const, and I think it's getting overwhelming just making variables. If this is your very first time, it's going to be a little bit confusing, but before the end of this video we'll be using a lot of course variables, and you will get to understand you'll get familiar with them, right? You'll understand. So don't one thing I want to give you for sure is that you should not just watch, you should practice, you should write your variables, you should just practice. If you're learning, that's the best way to learn programming. You actually do it in a hands-on field, right? You have to program. Just don't watch just like that and expect yourself to just remember. Okay, so I'll just leave it there for variables, and it was very quick, but of course you will get to use a lot of variables in your programming, right? Because you use variables all the time. And one of the difficult things you might notice with me is naming my variables. Not just me, actually, almost everyone programmer knows this problem of naming variables, right? So we will go to the next section now, which is we will see the built-in types. So see you in the next section. Now let's look at built-in types. So there are several built-in types in that, which if I haven't said this, that is obviously object oriented, and everything in that is a not a widget, sorry, that's Flutter. It's an object, right? Everything is an object, which is you'll come to understand when we get into OOP, because we will make our own objects, right? And we'll create their methods and everything. But for now, let's use the built-in types. So let's start with numbers. Obviously, with numbers, there are two different types in that. We have the int type, which obviously represents just a normal decimal number without normal integer, right? Without any points, right, or fractions. So that's just an integer, right? And we have another type. I'll just print this one. If you remember our print, you just pass it an object, right? And then when I run this, I'll just see 23. And then we have another type, which is obviously the type with the floating point numbers, right? With decimal places, decimal numbers after decimal point, which is called double, right? With double, we can put weight like that, and you just give it a number that has points after this decimal point. That's just double. They are just floating point numbers, and that's just what we have with numbers. We just have that. I'll just print this so you can see it. And the print actually takes strings, right? It takes string, but these objects we are passing, this int and double, they all have their string representation internally. As I said, everything's an object, but we can get that by saying, we come to just say the object name, as in this type is a weight of double, and then we will say, actually we will say weight dot 2, we can say 2 string, which returns the string representation of this object, right? As you can see, string provides a representation of this value, right? And don't stress yourself about this notation. I'm just trying to show you something, and then run. you can just see the same thing. Now that's numbers, and let's start with string. And I have already showed you this, where we can have something like name, and then we can just set it to something else, like Peter P. I don't know what that name is. So that's a string. Obviously we can just print it, string name, right? We will see that printed. But I want to show you something. We can also have a string like something like height, right? And then I'll say probably 178. This is a string. We put it in our codes, 178, right? And then I want to show you something, right? This is a string, obviously, and we can do something. We can change it from string to a number, right? If you want it, because obviously maybe you want to add something to this, and we can really add strings and numbers, but we can change it to string. So we can just say we can do something like this: int dot pass, right? And then we passed our string in there, and this will return it as an integer. Obviously you don't see any difference here, but if I assign int dot pass to int new, I'll just say new integer, and then I'll just do this, we're not going to get an error, because this new integer is an int, because we just changed this string, as you can see here, to an int by calling int, which is the type, and then dot pass, which is just a method. Don't stress yourself on this one. I just wanted to show you that we can change a string to an integer, right? And then we say new int, and run. You'll just see 178 again, but that is the string type. And just now we can change an int to a string, and then a string to an int when we want to, do something with it actually. So now we can look at another type called bool, which is just means true or false, and I can actually just call this something like is on, and then I'll say false. This is how we do it. Oh, sorry, it should be caps actually. The false, wait, false. Did I not spell it right? Sorry, I forgot my semicolon. So don't forget these semicolons, okay? And this is just a type, a value of false, right? With the bool type, you only have true or false, right? As you can see here. So you can also print it, obviously, is on. You can print it, and you just get false. And you can have true as well, which is just true normally, and that is bool type, so it just represents true or false. And in that, you don't actually have if you know any programming, you don't actually have truthy or falsy, where you have 1 as a true or 0 as a false. You don't have that in that, so just keep that in mind. And now let's move to another type, which is the type lists. I know you're waiting for this. So the type of lists is just a container, right, for other objects, right? You can have a list. I will just say call it test, like this, and then this is how you make a list, right, with the square brackets. What do you call them? Square brackets? Yeah, I think, yeah, you call them square brackets. So this is just a list, and obviously it has nothing inside. And I'll just print test, run, and now it will just print square brackets here, empty, without anything, as you can see. So as I said, list is just a container type which you can have different type of objects in there, which is kind of cool. We can have maybe 20, and then these are like test scores I'm making up: 40, 50, 60. You can have as much objects. You can have as much of objects in here as you want, right? It's just a container type. And if we print again, we will see you will see our list with those objects. Now you have them in one place, right? And obviously you might want to, at some point, I'll just comment this, right? At some point you might want to get an element within that list, right? Maybe you want to get this element 30, or you want to get this 60, right? I say element or object, I mean the same thing when I say element or I say object, but I'll just actually be saying object from now on. So maybe you want this second object, or you want this. So how do we get that from a list? Obviously what you need to do is just index through that list. It's called indexing, and then you just put square brackets. And with lists you actually start indexing from 0, right? It's indexed based container which you can access the elements, objects inside, with indices that start from 0. So the first element in your list always have the index of 0. So you can say 0 in here, and this will give you the first element, which is the number 20, right? So I'll just run this and I will see 20, right? And same thing for the next element. I will just see 1 in there, and I will get 30. And you can index like that up to the number of elements you have. Now how do you know the number of elements you have? Obviously this is a small list. I can just count 3. I have 6 elements in here, but obviously your list can get arbitrarily big, or you might not even know how many things you might have in the next list. So the way to know that is by using a method, right? I'll just use the print by using a method which is called length. So all you have to do is just say test. This is the name of your list, and then say dot length, and this will return the number of elements you have in your list. And I will run and I will see 6, because I have 6 elements, right? I have 6, but obviously we cannot index up to 6 because we start indexing at 0. So if you want to index to the last element, you just index to your length, right? I'll just cut this, and I'll just come in here and I will index, because the length, when we call length, it returns a number. That is the number of the elements, the objects in our list. And if we try to index with this number, which is 6, we'll get an error, because indexing, we start from 0, right? We start counting from 0 and then we get an error. But how to get the last element is simple. You just say -1, which will give you 5, and then we get 70, the last element in your list. So this is how to get the last element in your list. If you don't know the number of elements in there, just get the length and -1. So that is the length, and I want to show you how to add new elements to the list, right? So you can simply just say test and then say dot add. That's just how you do it, right? When you call add, you just add one element to your list. In this case, I will just add 90, right? A very high score. And if I print, like on this line, I'll just print my list again, right? If I run this, I will see from 20 to 90, right? I have 90. So now I have one new element in my list using the add method. And if I want to add not just one element, like I want to add maybe 3 elements, right? Like they are in a list, they are on another list. So I will just say test, right? I'll just come down here and say test dot add all, and I'll pass a list in here, which I'll just say 95, 23, 10, right? And then now I'll see 95, 23, 10 at the end of my list, right? Because I just added them. This is how to add several objects to your list with the add all. So that is another method. Don't worry, I'll explain what methods are very soon. So that's lists, and there's another method. I'll just show you 2 methods and then how to clear your list. Now with this method, I just want to show you what this is. If I say test dot, I have this convenient methods first that just return the first element in my list, right? If I run test dot first, I'll just see 20, and if I run test, you guessed it, last, I will see 10. Yes, because we added 10 into the list. So that's just 2 methods, test dot first and then test dot last. Maybe I should just put this here so that you remember. First, this is first. Now I have all these elements in my list, right? What if I just don't want them in my list, right? I'm just going to print the list, actually just show you. This is my list, and I just want to remove an element. I don't want the element anymore in my list, so I'll just easily I'll just comment these ones out, actually, just so we can get a clearer console. So I can easily just say test dot remove. I can remove an object, and I will just pass the object I want to remove. Maybe I just want to remove 95. Maybe it's very high score and I don't believe my student got that, so I'll just say 95. And if I run, I'll just print the test again so that we can see the difference. If I run, we are not going to see 95 in our list. It will be shorter. Wait, test dot remove. Sorry, oops, I commented this out. Test dot remove. This is our original list. So let's just try to remove something we actually have in the list, which is maybe 70. Let's remove 70. And then if I run, I will not see 70, right? I just removed 70 from my list. So I just want to show you what if I want to just clear everything from my list, right? I can just use the method clear. This is the method, and I'll print my list again, which is test. I will run and I will see an empty list, right? Nothing in there. So these are just very few methods. There are like, I don't know, maybe 20 plus methods on the list. So we cannot actually look all of them. They'll just overwhelm you, and with the more forward we move, you'll get to see a lot of different methods and how to manipulate lists. So that's list. Now let's look at the next type, which is going to be sets, right? And sets are just like lists, right? But they are unique in a way that you cannot have duplicates, right? In a list like this one, you can have, maybe you can have 20 and then you can have another 20, and it's okay to have duplicates, like the same numbers. As you can see, we have 20 and we have another 20 here. That's list, it's okay. With sets, it's just a container also, but you cannot have duplicates. If you know any sets, if you've done like sets in maths, you know what I'm talking about. So with sets, you just say set, all right, and then you give it a name that will say something unique. I will say planets. Hopefully that's unique. So this is how you make a test, a set instance with curly braces, and yeah, this represents a set. This is a set instance, and you can just start putting your elements in there, right? You can have, obviously we said planets, so I will have what what are planets? Mercury. I can have Mars, everyone's favorite. Earth is my favorite. You can have Earth. You can have Mars, Earth. What other planets are there? Venus, Jupiter. This one is huge. We have to have it in here. Jupiter, and yeah, this is our set. As you can see, they are all unique, right? No duplicates. And I will just actually clear this. It's kind of getting too much in here. I'll just clear my main. Sorry, if you want to like look at it, you can just come back to this spot and look at these methods. So I'll clear it, and then we'll use our sets. So first thing first, print, right? Print our planets, and we'll just see exactly this representation, right? Mercury, Mars, Earth. So we have our planets. Now with sets, you can actually check if a set has a value you are looking for. With the methods, you could just say planets dot, and then you say contains, and then you pass what you're looking for in the set. Let's look for Mars, and this actually returns bool, right? The bool type, true or false. So when we have the object we are looking for in the set planets, it will return true. If it's not in there, it will return false. And obviously we have it in there, and it will return true. We have true, right? Maybe let's just misspell it like mass, and then it will return false because we don't have this in our set. So that is contains. You're just checking whether it contains an object in there. How about adding a new object? Well, it's very simple. It's just like actually a list. You can say planets, oh man, planets dot add, let's add Pluto, no, Pluto. No, I don't think you add Pluto. Wait, let's just add Venus. We have Venus, Jupiter. That's all the planets I know. Wait, I know another one. I know Saturn. Yes, there's Saturn. Let's add Saturn, and then print planets. We will just print the planets, and we will just see Saturn in there, and we can remove Saturn, or we can remove from a set. We have Saturn, and we can remove with the remove. Just say planets dot remove. Maybe I'll just want to remove I'll remove Mercury. I don't like that one that much, so I'll just remove it, and I can run, and then Mercury is gone. Yes, so you can add remove, and you can say contains to check in there. There are other methods you can use, but we can't look at all of them. And let's look at actually one more or two more. Intersection, which says you do this to see whether a particular set's elements are actually in a different set, right? That is intersection, right? We say set. I'll just make a new one I'll call it bucket list, and I will say Mars mean, this is just an example, just an example. So let's put Saturn. Actually, let's put Saturn in there, and I'll just actually comment this, right? I'll just comment this also, but I'll leave the Saturn in there because I want to use the intersection. So planets dot intersection, right? The intersection is a method that checks this set, right? The one you call the method on with the one you pass, which I'll pass the bucket list set, and then it will return a set that will actually show you the what they have in common, right? For instance, when we run, we will see that it has Mars and Saturn, because the planets also contains Mars and Saturn, which is the intersection, what they have in common. If we run, we see Mars and Saturn because that's what they have in common. And obviously I can add something here that is not in the other set, like Uranus, and we will not see Uranus because it's not common to both sets. Like this, as you can see, Uranus is not there. So that is with sets. Actually, I'll leave it like that with sets because there are again other methods. There is actually what you call this methods, difference. There is the difference method, which will show you the difference, right? The elements contained in one set but they are not in the other set. That's the difference. Now that's actually enough of sets. This is getting very long. Let's see our last built-in type for this section. So we have a type of map, right, which is a container type also, but it associates keys with values, which associate values with keys actually. So we can say, let me just show you. I'll call this test. I'll call it test scores, like that, and I'll do this. Now you might be saying, wait, is this not how to make sets? Well, yeah, it is, but this maps actually takes precedence over sets. If you do this, it will create a map, right? For instance, you say var, right, and you don't specifically declare the type. Now var will infer this to be a type of maps. Let me just hover over test scores. As you can see, it's of type map, because again, when that sees this and with a var, it just takes it to be a map, right? Because maps comes before sets. So that's how to make maps, and obviously we will see type annotations later, but for now we're not going to go there. It's going to be a lot to take in. For now, this is how to make a map, and a map is, as I said, is associate values with keys. So you can have your keys. I can say, because this is a map of test scores, I can have a key with the name of the student, like I'll just use my name for now, and then you put a colon, and then you put this is test scores. So a reasonable thing is to give this a value of an int, right, for the test score. So I'll just say 90. You know, I scored a lot, and I can have another key, and of course they are separated with commas. I can have another key. I can say the name like Sarah, and I'll say maybe 85. So I'll have Peter, right, and I'll have maybe Peter did not do good, right, that 5. And this is how you make maps, right? As you can see, this key is associated with this value, right? And I'll actually remove this. So let's just print our map, run. We will just see this representation, obviously. So that's just it. And to see what I mean by it associates a value with a key is, we can just say, I'll put it in a print again. I want to get the value, the test score of my student, who is called Peter, right? It's already in the map. So when I want to get Peter's test score, I just go into my map. I'll just say test scores. I will use square brackets, just like I'm going to index like a list, but instead of passing indices of 0 to whatever, I can pass the key, right? I can pass Peter, which is the key, and this will return the associated value, which will be 35, right? And we get 35, right, for his test score. And this is how to get the values associated with keys. So this is like you remember this more often than, you know, memorizing indices for your list, right? For saying maybe the score 30 is at index 1, because we start counting from 0, so index 1. But with maps, you just associate it with keys like this, and you get the values back. So that is how to get your values in a map. And there are actually methods. For instance, you have, if you want to get all the keys, right? All the keys. I want to get all the students that wrote the test, all the students that wrote the test. I don't want to even see the values. I can just say test.keys. And now these keys will actually return only the keys of the map, in this case the students, right? So I'll just do that. Sorry, this is a map actually. It's said test scores, not tests, right? I'll say keys, test scores.keys, and this is how you do it. It's a getter, so you don't need just brackets. And if I run this, I'll just see the name of the students. Those are the keys. And you guess it, we can also get the values just by saying dot values, and we will get the values. Those are the values, and these are just methods that are convenient, and we'll see how to step through these keys and values later on. But for now, just know about these methods, right? And if you want to check if a map actually has a key in it, right, we can just do test scores dot, and it contains, right? We can check if it contains the key or the value, right? Contains key or contains value. So I'll just check for a key of, maybe I want to check whether this student has participated in my test. I'll just say Iron Man. Did Iron Man participate in my test? No, probably not. He's too proud. So I will just run this and it will return false, because we don't have that key, and as you can see, it returns false. And we can also say it contains value, right, which I saw. I'll just put a score of, I'll actually put something that is in our map, like 85, and then I'll run. I will see true. I see true. So that's just how to check in a map, and there are several methods. Again, we'll see them when we get into Flutter, because we'll actually be using that to write Flutter apps. So we'll see all of them, but for now that is our built-in, and we're getting to the parts you might consider difficult if you've never done programming, but we're getting into the next section, which is about functions. So I will see you in the next section. Hopefully you are all there with me. It's about to get very functional. Okay. All right, functions. So I'm just going to clear everything, and well, we've been actually writing a function called main like this with all our programs actually. So this is just a function, and let's just do the explanation. But the main is actually where we start running our program. So I'll just make another functions because we don't actually call this to run the program. So let's start with a very simple one. I'll call it say price. So this I'll just type string, and then I will call the function say price, and then I will just say return. I'll just return the price is 15. I don't know. So explanation, we said string, right? So this is how you make a function, and the first thing you type actually to make a function is the return type. So what the function is going to return actually, right? So we said string, as you can see we indicate with the return keyword that this is going to return a string, and this is the string we are returning. And then this say price is just the name of our function say price, and then to indicate that it is a function we use these brackets right after the name, and then to give the body of the function we use curly braces like this, and whatever is inside this curly braces right is what is going to run whenever we use our function. The body will be run, right? The body will run, sorry. So let's see what I mean. I can just say I'll just make a variable string I'll just call it my string, short like that, and then I'll call my function say price. Now this is how to call your function. You just put these brackets right here, and then you are actually calling the function. You are actually saying the function to run, right? The body of the function should run by putting this brackets. So what I can do is print my string. Right now we will just see this return statement, the price is 50. So this is how to make a function, right? A return type, the name of the function, right, and then the brackets to indicate that it is a function, and then the curly braces to give the body of the function, what is going to run whenever we say price. We call the function like this. Now I can do something. I can say print this just to show you, print say price. Now I'm actually calling the function right without even assigning it to a variable, because the print takes a string. So I can just do this, right? I can just call say price, and actually right here as you can see I missed my brackets, and if I run this we're just going to see the function, the name of the function, just some default preview of what a function is. So as you can see, it said closure say price, and I forgot to call, that's why. So if I put this brackets, as I emphasize, brackets is how you call a function. You run, and then I will see the price is 50 again. Now that is the function, very simple. Now let's move to look at this. Now this function is pretty kind of dumb, right? Like whenever we call it, it just says the price is 50, but we want to make it logical, like dynamic, right? We want the price to be changing, right? Whenever we call the function, we want to kind of pass the price we want to actually say, right? So this brings us to parameters, and now this these brackets, within them, inside these brackets, this is where you are going to put your parameters. Now parameters are just values you pass to a function, like the input of a function, right? And then this return is the output. So we call them parameters. Now I want the price to change whenever I call this function. I want to be able to say this is the price I want the function to use. So this brings us to parameters, right? And in that we have positional parameters. So I'm just going to make a comment and I'll say positional parameters, and then to make a positional parameter, we just come in here, and then I will just call it int price. I'll call it price. So what this means is, as you can see, we get errors here, but we'll fix those. So I just give a type and then a variable name of the price I want to use, right? So in here I will use string interpolation. We've seen this before, and then I'll just say price, this value, whatever we pass as the price, we should use it here. And now these guys are giving us an error because we forgot, as you can see, we forgot a positional argument. Now you can say arguments or parameters, whatever one you want, but specifically actually when you're calling the function, that's when you say arguments, but you can interchange them. Okay, so now we will just pass the price we want to say, right? So I want to say the price 25. I don't know what that is, but here I want to say a price of 50, right? As you can see, we are using the same function, but we are passing different prices, right? So it's a bit dynamic. As you can see, we have the price is 25, the price is 50. Now yeah, it's a bit dynamic, but still it's not that fun to put it in a function. And what I want to take away from actually what we just did, positional parameters, is that you actually have to pass these parameters, that like they are not optional. So I think that brings us to our next parameters, which are actually called optional parameters. It's actually difficult to talk and type, so I'll just copy this function and then I'll just paste it, and I'll just remove this parameter, and as you can see, we have just a normal, actually wait, we should rename this. We can have the same names, so I'll say price 1 just to make it different, and then I'll just remove this. So now with optional parameters, how you actually make them optional is saying square brackets like this, and then you say the parameter you want to be optional, in this case the price, right? And then I say interpolation price. So this is optional, and when we use it, when you use say price 1, say print say sorry, I'll just call say price 1, and I'll leave it like that, and we don't get an error because it's optional. And let me just show you the difference. If I remove this, we get an error because positional arguments or parameters are not optional. If you don't pass them, you get an error. So just Control Z, and in here, if you run this, we're actually going to see something we don't want to see ever in programming. If you're programming, you don't want to be getting these values, except if you're going to use them for something. But this brings us to our first no. Let me show you. Yep, our first no. It says the price is no because we did not pass any price, and we are using this local variable price. Now, what I mean by local variable is just simple. It means that we can't actually access this variable anywhere else except within this function. We'll look at it further in details in the next section, or 2 sections to come actually. So optional parameters, right? This is how you make optional parameters. Actually, this function is kind of getting boring, so let's do something else. Let's do let's make another function, say price 2, and then it will just return the price is just say price. Actually, the price of, I want to make 2 parameters, the price of, and then I will just say item is price for now, and what I want to pass in is the item and the price. So we can actually have 2 parameters, or as many parameters as you want. So I will just say still item, right? So it should be string item. Whatever we pass in here, we're going to use here, and then int price. Now I'll just change these variables, price, and then I'll just change this one to item. Now when we use say price 2, like this, print say price 2, say price 2, we'll get an error because we have to actually pass those arguments, item and price, and because they are positional, we will have to pass them, right? 2 positional arguments expected but 0 found. We are expecting item and price. So I'll just say the item is, maybe I'm an iPhone 12. The price is, I actually don't know the price. I'll say it like $6.99. I don't know. But this is just going to run. It's just something normal, right? But what I want to show you is, as you can see, what I want to show you is because the parameters are getting, we have several parameters here. Actually, you have just 2, but imagine if you have like 3 or 4 parameters in here, and then the function is in another file. You cannot see the function and you want to use it, so you have to remember exactly how to pass these parameters, because the item has to be the first argument you passed, the second has to be the price, and then the third, and then the fourth. You have to actually remember the arrangement. So this is not actually good, right? So what if we can have a way to actually specify what we want to pass? For example, I want to pass price, right? I will just say price. For example, I'll say price colon, and then actually this shouldn't be price. I should say item colon, and then pass item, right? I don't have to like pass them in order, right? In order how they were defined in the function. I can just use the keyword item and then pass the value. So this brings us actually to the third types of parameters you have, which are called named. named parameters. Named parameters. That means you just have to pass the name of the parameter you want to pass, and then you pass the value. And how to do that is just with curly braces, right? You just put these curly braces to wrap whatever parameter you want to make named, like this. And then here, as you can see, I can see item, and then I will say price, and I am passing the price. And then let's just run. It's just going to be the same. And what I want to show you is that it doesn't matter what we pass first. I can pass the price like this, and then pass the item as the second argument. I will say we had iPhone 12, so let's just iPhone 12 and then run. It will still be the same because these are just named parameters. We just give the name of the parameter to pass, and then we pass it. And we can actually totally not pass all the parameters. We can just pick the parameters we want to pass and then pass those parameters. And I mean, it won't throw an error, but it will give us null, right? So if I haven't explained null, is that it just means this variable is actually pointing to nothing, right? It has a null value, right? So that's just that. So now let's move on to what's called items as first class objects. This is actually very powerful concept, and it will lay the foundations of doing all those anonymous function and all of that. Now what that means, what functions as first class citizens or objects means, if you ever heard this somewhere, is that they're actually just like variables. So I'll just actually remove all of this. They are just like variables, functions, right? That means for example, here my string, we are assigning it to say price, and then we can actually just do this without calling say price, but actually, sorry, let's use say price 2, say price 2. That's what we're going to use, and we get an error because this is just a function and we cannot assign a function to a type of string. So what we can do is just remove this, and then we can just say var. If we say var, we are not going to get an error because var will just automatically infer the type. And now when I hover the string, you can see that it's actually a type of function. As you can see, my string, this function is actually, this variable is of type function, and it actually takes two parameters, item and price, and it returns a string. Now this might seem difficult at first, but it's actually very simple, because I will show you one thing is that this is a function name, right? And then we can just assign it to a variable, and we can actually do something like this. We can say print whenever you want to use that my string, we'll just say my string, and then I'll put this brackets. That is how to call, and then I will pass the item, which I will just call MacBook. Let's just say MacBook, and then I will say, wait, next parameter price, which will be how much, 1,200, I don't know. So this is, as you can see, this is my string. We are just assigning a function to my string without calling the function. That means my string is now pointing to a function, right? And then we are calling my string later on whenever we want to call it down the road, wherever we are. We just call it, and then we pass the values we want to pass and run. We will see MacBook 0. How did I put this 0? And we will see that. So this is what it means, because we can assign functions to variables, and we can do something else like like this. Actually, I will just make a new function. I have to remove all of this. If like this, and actually just have a clean slate. Now I will just I'll just make another function just to make the function sink in. This time we will return an integer, right? An int, and I'll call this add a and b. It will take a, obviously, and it will take b, and they're all actually positional. But actually I will not use curly braces. I will use a very cool looking syntax. It's called the arrow operator, or the fat arrow syntax. So this just means return whatever we write next, right? If you have the arrow, next thing is return. It's going to return whatever you have next. So in this case, I'll just say a plus b. So it's going to return a plus b. And to make that sink in, I'll just do print add a and b, and then a will be what am I doing? If 10, this is going to be 5. So it's quite simple. Wait, I missed something. The b is capital. So add a and b, run, we'll see 15. Nice. Now this is basic simple functions. We can look at anonymous functions, which are quite simple also, because anonymous functions are just functions that actually don't have a name, right? You don't have a name to call those functions, like this one, add a and b. So we'll make a simple example. Var, we'll make the version of this, which is I will just call it add 2 ints. Call it add 2 ints, and then this is just a variable. Now this is where we make the anonymous function, and how to make one is just very simple. You just a normal function, but without putting the name. So you have your brackets, and then I'll use the arrow operator actually, and then whatever comes after this, we know it's going to be the return statement. So actually this is add 2 ints, so we'll take arguments, right? And then we will just return a plus b. Now we use anonymous functions in places where we cannot actually use a full function with the body and everything, right? Like this. So what I will do is just show you how to actually use this, because add 2 points is now of type function, because it references an anonymous function. And then we can just print add 2 ints, say add 2 ints, and when we're going to call it, we just pass this 2 ints, and this will just be 20. So this is what is an anonymous function. It does not actually have a name, right? And you can pass it any way you want, including in a parameter. For instance, we can have a list of ints. If I haven't shown you this just means a list of integers, and whatever else we put in there is not it's gonna throw an error, right? If I put 10, 20, oh sorry, I didn't give the name. I'll say scores, like test scores. So maybe it should be like 40, 50, 60, 70, 80. I'll just leave it like that. And we have a list of scores. Now what if we are trying to be generous, right? They wrote the test, maybe they did poorly. Actually, I'll just reduce this number so that it kind of looks like the students did very poor. So this will be like 30 like that. All right, that's poor. So what if I'm feeling generous and I want to add a bonus, right, to all these scores, to all the people that got those scores, right? So I can do something very simple. I'll say scores with, this is just a name of a variable, scores with bonus will be, now in the list we can say scores dot map. Map is a very good example of a function, of a method. They call it method. You will know what a method is, but it's just a function also that takes a function. As you can see, it takes a function like this. And when you see a function that takes a function, that's called a higher order function. There's a function that takes another function, and the map, as you can see, it takes another function and it returns an iterable, which we will look at. But for now, just know that we can pass a function in the map, and actually with the map we get something like this. We can pass a function, right? So I'll just do this. If you remember, this is how we make an anonymous function, just like here. So we are passing the anonymous function, and then the aim is to add a bonus to each of these scores, right? So we can say, I will say score. This score right here is the actual score from our scores. It's 1 is like, for instance, this is the first value, right? This score will represent the first value, and then in the next iteration this score will represent 50, and then it will represent the next value, and then the next value. So what map does is it actually applies a function which we are writing here to each element, each object in the list, like this. So we said we want to add a bonus, which will be score plus the bonus, we'll say bonus of 10. Actually, I would say score plus, yeah, score, the bonus is going to be 10. And this is actually not going to give us what we want. If we print, just so I can scores, just so I can show you what an iterable is, scores with bonus. And if we run this, we're going to see some weird thing, right? It will say iterable something. Oh, actually it did not. It actually returned the iterable, the string representation of the iterable, but the map function returns an iterable because we are putting it in a print. That means it will return the string representation. But as you can see, the list, we have all the values have now 10, right? Added, they are been incremented with 10. As you can see, this first value is 40, but here is 50, and we have 60, and we have 50, and now it's 60, and the last one is 30, and we have 40. But as you can see, this is actually a bracket, not a square bracket like a list. So that's how you see iterables when you print them. So what we can do is come here, or actually here, it's an iterable, but we can say dot to list, which will actually convert this iterable to a list. Now we will see a list. We have a list, right? And we have actually incremented all the scores with our bonus. So this is an example of an anonymous function, and where you use them like this. This is an anonymous function. And one funny thing is that if we wanted, we can make our anonymous function like this, right? I will say anon, or I'll just say add, let's call it add bonus, which will just be an anonymous function that takes a score, and then it will just say, it will return that score plus 10, right? And then what I can do is, as you can see, this is exactly the same as this, so I can just remove this, and then I'll just say add bonus. Now this might be confusing, but when we run this, I'll just remove this. Actually, yeah, I'll remove the list so that we see the difference. That is actually has worked. Wait, let's comment this out, and then if I run, I will see, yes, it worked exactly like the other one. They are all added 10 10 10. It has been added to each element, and you might be confused with this, but it's actually quite simple, because add bonus is a function, right? An anonymous function that takes an integer, right? So all we need, actually I'll bring back the other representation, and then I'll just copy this, paste, and then I will use add bonus here. I'll say add bonus, and then I'll say scores with bonus and none, right? Now the difference is just that we are not writing the anonymous function directly in here, and we are just writing it. Actually, I'm missing one. No, I'm not. So we are not writing the anonymous function directly in here, right? But we are writing it somewhere, and we are assigning it to a variable. And because this function and the one we wrote here are exactly the same, they take one integer, one parameter like this, the score. This one also takes the score, is of type int. Actually, I can also write the int here, right? So because they are actually the same, they have the same signature, like the same parameter and the same logic, right? Like this. So I can just use this, the name of this function in here, because they are totally the same. So that's just how anonymous function works. And this can actually be called a closure. If you haven't seen it before, it can actually be called a closure. So that is actually anonymous functions. It's quite easy, right? All right, so now let's look at control statements, right? Control flow statements, right? How you control your program, right? If maybe you don't want it to run a particular line except a condition is true, or you don't want it to run as at all, or different ways to control the flow of your program. And with that, we do that with these statements, and we'll look at all of them, right? We look at if statements, right? If and else. This is very simple. You just say if, and then the condition right here, condition. If this condition is true, then we run the body. Now, I'll just say var condition is equal to true, right? And then if this is true, then we print condition is true. Else, we say else. I'll just say else print condition is false. So if else statements, if this is true, we run this body, and then we skip the else, and then we continue our program. If it's false, we don't run this body, then we run the else, and then we continue our program. So this is true, of course we'll see condition is true, and then I'll change this to false, and then we'll see condition is false. Great. Now we'll look at for loops. So with for loops, we can just basic for loops like this. You can say for, and then you declare a variable, your variable, and then your condition to continue looping, and then an increment which will make this condition false as the loop goes on. So an increment actually, or a decrement of your variable. So let's just declare those. So I'll say var, or I'll just say int I is just 0. The condition is I want to loop 10 times, so I'll just say I is less than 10, and then I'll just increment I plus plus. If you haven't seen this, the plus plus is just saying add 1 to I. So it's just saying add 1 to I. It's a postfix. It's called a postfix. That means it will just add 1 to I after it has used I. But I'll bog you down with that, because if you have it just like this, it's just going to add 1 to I. So plus plus means add 1 to I. We actually have minus minus, which means remove 1 from I. But if we run with minus minus, our condition will not be true. So I'll just say print, I'll say I is at I'll say index, then I'll just print I, the variable I, this, and then we should see, just comment this and this, and now we should see I is at index 0. It will start from 0, and then it will keep going up to when this condition becomes false, which is when I is 9, this will run, but as soon as we increment to 10, it will not run. So we will not see I is 10, but we'll see I is 9. Right, now we see I is at index 0 up to 9, because we start from 0, we stopped at 9, and actually this is exactly 10 times. So that is a for loop. And a bit more explanation is we actually run this first, and then the condition, if the condition is true, then we run the body of the for loop, and then after running the body, then we do the increment, and then we check the condition, and then we run the body, and then we do the increment, and then we check the condition, the body, the increment, the condition, and then if it fails, we don't run the body and don't do the increment. So that's just a for loop. And that is another type of for loop, which is different, which you can actually use to loop through lists or any iterable. So I will just have, I'll have a list. I'll just call it scores. I think we've beat this horse for a lot. So scores, and then 10, 20, 30, 40, 50, and then the other type of for loop is, you can say for, and then now you just say var, and then I'll just call this item. This is just a name of a variable, and then I'll use in. So the in operator or keyword is actually saying, actually let me just finish it, scores, right? So the in is saying inside scores, right, for each item in our list, right? We run this body. For each item in the list, we are going to run this body, which is obviously a very simple print. We are just printing the item. Now actually I'll comment this, so we can see. If I run, I'm just going to see all these items printed in one lines. Actually, I'll just say the score. The score is, and then I'll say item, and I will run. And we saw the score is 10, 20, 30, 40, 50, up to 50, all elements in our list. Now the difference is that with this type of for loop, you use it to loop through lists and other iterables. But the thing is, with this for loop, you actually don't have access to an index, right? If you want to like use an index, for example, here we have I, which is showing us which iteration we are, like which number is I, right? Is it at loop 0 or loop 1 or loop 2? But in here you don't actually have any index, so that's just a major difference between these two. Now let's look at while and do while. So with while and do while, you just actually have to have a condition. I'll just say actually a counter. I would say var. I'll just say counter, and then I'll say 10. So normally this is how you're going to have you're going to have this variable counter, which is here it says 10, and what it means is that this is how many times you want to loop, because with a while loop, right, this is how you make it. It has a keyword. With a while loop, this is the condition, counter is less than 10. I'll just finish that so that I can explain. Say print, say counter, and then counter plus plus. Now, oops, sorry, I should actually put I'll put a less than, I'll put a greater than, I'll put a less than, and then I'll just make this 1. So sorry about that. You usually have a counter which you will be using in the condition, because a while loop, if you just say while some variable that never turns to false, this will just keep running and it will actually draw some sort of error of memory, some sort of out of memory or something, technically an infinite loop. So with the counter, you just check the condition in here, and then inside the while loop you change that counter. You either increment it or decrement it, so that in the next run this condition might be false in a way, so that you can end the loop, right? If I run this, I'll just get 1 to 9. So that's just a while loop. And you can actually end a while loop by saying something like, actually I'll just remove this. You can end a while loop by simply checking, I'll just check a condition, if counter equal 5. Now this is another operator, it's equal, it just checks if counter is the same as this. So if the value of counter is 5, then it is equal 5. So it's the same, because the reason why I have 2 equals is because, as you can see right here, 1 is for assignment and these 2 equal signs are for equality check. So I'll just say if counter is equal to 5, I'll just use the break keyword. Now this is where we are. The break is just going to do what it said, right? It's going to break out of the while loop, right? So I want to break at 5, and if I run this, we're not going to reach 6, 7, 8, 9. because this condition will become true and then we will break. Let's run, and we stop at exactly 4. Actually, we are not even printing yet because we increment before we check the condition. So if I just move this down, right, now we'll actually print 5. Yes, we print 5. So this is another way to break out of our loop using the break keyword. And to show you what the continue does, right, I'll say for var I equal to 0, I less than 10, and then the increment or decrement, whatever you want to do there, I'll do this. So this is just a loop that will loop 10 times. Now if I'll just check if I is at 5, then I'll just print I, right? Sorry, maybe I should just use the continue. Now before that, I'll just say print I. Now what we're doing here is that we are checking if we are at the 5th loop. If we are at 5, if I is 5, then we should just skip this current loop. That means we skip the rest of the loop, and then we will not print anything at index 5. Then we will just move to the next index, which is index 6. So when we run this, we're going to see from 0, but we are now going to see 5, right? But we're going to see 6. So we're going to see up to 4, and then we'll skip 5, and then we'll see 6. So if I run, as you can see, we skipped, right? This is 4 and then 6 because we skipped 5. That is what continue does. It lets you just move on to the next iteration, to the next loop, right? So that's continue. Now you might be saying, do while, did I skip this? Well, do while is just like while, but the difference is quite simple. It just says do, right? Do, and then the body, and then while, and then the condition. Now what this is it will do this body, whatever you write here. I'll say print I'm doing it. I'll say I'm doing it. And then we'll print this once, right? And then we'll check the condition. So a do while loop prints does the body of the do at least once. So I'll actually just put a counter and say equal to 0, and then as long as the condition counter is less than, I'll just say do this 5 times. I'll increment counter. So what this will do is that it will print this, and then it will check the while. So we will see 6 prints actually. Let's just run that and see. So we see 5, sorry, less than. If I put less than equal, that's when we will see 6, sorry. So what it does is just do this body at least once before checking the condition. So that's control statements in that. And I know this section was maybe a bit boring for you. I mean, it's kind of boring actually, but let's move to the next section, which is actually going to be classes, right? OOP, object oriented programming. And this is actually the most exciting part yet, I think. Yeah, okay, we'll see about that. And then yeah, let's get into OOP in that. All right, OOP, right? So object-oriented programming in that, obviously. So if you're actually new to OOP, object-oriented programming, then you might want to watch this part. I'll just try a very simple explanation, and then we will write our own classes, right? Our own objects. So uh, I've already shown you some objects, but they are built in, right? Like they come with the language, like a string, right? Like a string, an int, a float, sorry, a double, it's called a double, a list, a set, a map. Those are all uh, built-in objects, right? So as I said, if you are new, you might want to watch this part, and then let's just start the explanation. So what do I mean by objects, right? Just look around you and see stuff like a laptop, right? Like a car. A car is a good example. So a car, let's take a car for an example, is an object. And that car, let's be specific, let's just pick a brand like a BMW M8. It's a car, right? And that car has it's an object, right? And let's take it as a blueprint, right? We have our classes, which I will explain. It's just a keyword like this class, which is a keyword that we use to make our own objects in that, in this case, object of a car, a BMW M8. Now we'll take this as a blueprint, right? Like we have a blueprint of how to make an M8, and we can make as much M8s as we want from just that single blueprint, right? We can make 1,000 M8s. They will all be the same, but they'll just have, because they are from one blueprint. So that is a class, right? The blueprint is just how we make the M8, right? So, and also as I said, we can have as much M8s as we want, but the thing is, the M8s, they have methods, right? Let's say functionality, right? This is they are called methods in programming in OOP, which is just some functions like ignition, right? A car, obviously you have ignition, you have acceleration, you have braking, you can have honking, right? Actually, I'll write those like this. You can have these methods, they are called methods, and they are also in our class, which is our object. It can do all of this. In this case, we are saying a car, right? A BMW M8. It has ignition, acceleration, braking, honking. It can do all of these things, and all those different cars we make, all those cars, real physical cars that we make like in the factory from the blueprint, they will also have all of this, right? So they'll also have all of these methods. They have ignition, acceleration, braking, and honking, and other things. So that's just the process of making those actual physical cars, those BMW M8s from the blueprint, is called instantiation, right? To make an instance of that class, right? To make an instance, to make that physical car from the blueprint. That physical car that you made from the blueprint is the instance. So that is instantiation. If this is the first time hearing it, it might sound weird or something like that, but you will get to see a lot of examples as we move on. So that's instantiation. And one thing you should know is that these objects, these physical instances we make, they might have their own different let's say actually properties. I'll say properties, which is you might have a blue BMW M8 or a green one or a red one. They are different, right? In those terms, right? In the color and maybe the size of the wheels, maybe, and then maybe the chairs inside the seats, maybe they are, you know, they are different. So that is what's called instance variables, because with each physical car, with each instance, you can have those different properties. The colors, right, can be different. So those are instance variables. Every instance, every physical car has its own instance variables, and this instance variables changes, right? Let's say like a mileage on a car, right? Your own car, your own physical car that you bought, the BMW N8, your own, will quite obviously most probably have a different mileage from another BMW M8 that someone owns, right? So another instance will have different mileage than your own instance. So and obviously that other person driving his own car, the instance, right, or that other instance, can change the mileage, right? He drives a lot, the mileage changes, increases, and obviously it does not affect your own mileage in your own car, right? So that's instance variables. They change, and each instance, each physical car, as in this case, has its own different instance variables, right? And they also change, right? Like fuel, you can have your own fuel in your car and you might keep it at home, you did not drive, and someone else has his own fuel in his car and he drives, and then obviously his own fuel and the driving will not affect your own fuel in your car, right? So it's all different. Each instance has its own different variables. So those are instance variables, and there are also class variables. Yes, class variables. So class variables are actually from something from the blueprint, right? They are class variables. That means they are actually shared. They are they are the same in all the instances, right? So all the instances have these variables. They are not different for each instance. All the instances share this variable, right? They are the same. So an example with the cars again is let's say the engine, right? The horsepower you have. So from the factory, we make an M8, and we say maybe they have like 640 horsepower, right? The engines, that's how strong they are. And well, with each physical car we make, with each instance, that will be the same, right? The horsepower will be the same. So each car is going to have, each instance will have that horsepower. So those are class variables. They are the same within all these instances. So I hope you understand those are quite important, instance and class variables. And we have let's see what's the most significant thing to explain again. Okay, actually just get into inheritance, which is a very big feature, very useful one to know. Is so inheritance is just a relationship between these blueprints you have, these classes you have, right? That is uh, inheritance, right? So it means you can have a class, right, that can inherit from another class, it can inherit all the methods like this one, right? Like ignition, acceleration, braking, honking, right? From just that BMW M8. Again, let's come back to our example. From that M8, right? You can have another blueprint, which is example, the M8 competition version, right? There's an M8 competition, which is an M8, but has some other features specific to the M8 competition. And the M8 competition can actually inherit from the M8, right? It can inherit all these features like ignition, acceleration, braking. They are all the same, right? It can inherit. So that means we actually don't have to remake these these methods in our competition version, right? We don't have to make these methods again because we inherit them, right? So the class that inherits is actually called like a subclass, and the class you inherit from is the super class. So that is inheritance is a relationship. So with the M8 competition, as I said, you can have these features, just inherit them. You don't have to actually write them. But like the class variable that I talked to you about, like the engine, right? The power it had in the M8, it had 640, and now that you inherit, right, the M8 from the M8 competition, you inherit the M8 competition from the M8, you can have a different class variable, right? That is the horsepower. You can override that horsepower, which will have more horsepower. Obviously, the competition has more horsepower, right? You can have it to be like 700 horsepower. So that is inheritance. That means you don't actually have to rewrite the class. You can just inherit features from the super class, and then you can you can override them if you want, or you know, make them specific or unique to the class you are inheriting, like the M8 competition, right? And you can have maybe something else for the M8 competition. You can have like the body kit is more sporty than the M8. So that is just inheritance. That's very quick explanation, and I think it's getting very long, but let's get into an example so that we can understand all of that very quick. So let's get started now. For an example, we will do something else, something that's not going to be very big, but it will show all those things I explained and even more, like abstract classes and mixins, inheritance, everything else. So let's get started. We will have for this example, we'll actually have a person, much easier, a person class and a person object. Let's say the blueprint, right? We have the person object, or you could call it a class, and we will now have instance variables. So we will say var, right, name, var age, so obviously a person has those, and then we'll have a job that will be 1. So these are actually instance variables. And let's look at constructors. I have not explained those yet, but constructors are just functions, as you can see, functions that have the same name with the class. So with the constructor, this is actually a constructor. It just looks like a function, but one thing we can do is I'll put curly braces here so that it will be named parameters, and then I'll say this dot name, and then I'll say this dot age, and then I'll say this dot job. Now this might look confusing, but all I'm saying here is this refers to the instance, right? As I told you, we can make as much, the person, we have as much people around you, you can make as much of those as you like. So this refers to each individual person, right? And each individual person can have different name and age and job, right? We don't all have the same name and the same age. So this is referring to the instance of the person. If we'll make the instance very quick so that you can see. So I will go to my main. Where is it? Main. And then to make an instance, I will just actually give it a type of person, because we said this is an object, right? We are making our own custom object. Just like strings, we can give the type of string. So this is a type of person, and I'll call it I'll say Sarah. And then to make an instance, you just use the name of that class, right? Person, like this, and then you call it like this. This is making the instance. But obviously right here in this, what we call constructor, we have these variables we are passing. So I will just pass the name, right? And then I'll say Sarah Ra, and then I'll pass the age. I'll say 21. I'll pass the job. I'll say data analyst. So this Sarah is now our instance type person. And to make this even more concrete so that you understand, I will make another instance. And as we said, we can make as much instances as we want. So person name Ahmad, age I would say 21. Wait, no, I have the same age. I'll say 20. Job, I would say developer. Now we have another instance from this, let's say, blueprint, this class, right, of a person. We can have different type of people, of course, and yeah, this is an instance. So coming back to this, the reason we can have as much instance as we want, right, and then have different variables for them is this keyword, because this will now refer to Sarah, right? And then when in this Sarah instance, this will refer to Sarah, and this of the age will refer to Sarah's age, and this job will refer to Sarah's job. And again, we have another instance of Ahmad, and then this name will refer to his name. So this is just a blueprint, right? And we can have that. So if we just do something like this, this is accessing an instance member, right? Accessing, for example, we can say Sarah dot, we can say name, right? And this is accessing the name, Sarah's name. So if we run, we'll just see Sarah. And I can say her job, and I can say her age, and we can access the name, job, and age with the dot notation. If you remember something, when we have something like this, print and then we have like a string, right? We say this, I'm just making a string here, which I'll just say hello, right? And if you remember, with a string, this is just a string literal, which is an instance of a string, right? And we can do something like this from that string. We can say dot, and then to say to uppercase, for example. And as you can see, we are accessing this method from this instance of string. So we have an uppercase of it. So now we can do something like that with our classes, right? We can say, I'm just gonna do this, right? We can say, actually now we are looking at methods, don't get confused. We can say, I can say string, and then I'll just say get name, which is a method. Is just a function. Actually, it's just a function that's inside an object inside our class, right? So I can just say this dot name. Now this get name is called a method because it's inside a class, and we can use it to get the name, as the name of the method says. So we can do something like this: print Sarah dot we can easily say get name, right? And the thing is, if I run this, we'll just see the name, but I'm just trying to show you what a method is. So it's just a function. Now let's get real with this example. So this is called a constructor, and this is actually run. It's called right here when you are making an instance. This is automatically called. As you can see, this is where we pass the name, age, and job, right? So this is automatically called when you are instantiating. This will run right internally. So that is just one constructor, and you can have different type of constructors. For example, you can have a person dot let's make a jobless person, right? And it's the same, right? This dot name, this dot age, but the only difference is that obviously the person is jobless, so I'll just say this dot job will be new, right? So he doesn't have a job because this is a constructor, but it's called a named constructor. So what I can do is say I'll just say person dot person Bobby. I'll just say Bobby, and then person, and actually now I'm going to use the named constructor jobless, and then all I have to do is pass the name and the age, 32, and yeah, that's it. I pass the name and the age, and he will automatically not have a job because we made him this instance from the jobless constructor. So this will, when we make the instance from this constructor, the named one, it's the one that will be called when we are making the instance. So we can just say b dot, if I find the job, it will just be null because this is what ran the named constructor. So you can have a person, you can have a jobless person, you can make them from this person class. Now that is a person class, and obviously this is just a method. So now let's look at getters and setters actually. So with getters, they're just simple actually. Getter means how to get an instance variable, just like this Bobby.job. This is actually a getter, right? But this is a getter that's made automatically by that. So whenever you make an instance variable like this, that automatically actually makes the getter implicitly. And also there's something called a setter, which you can do something like this. I would say, as you can see, the job set no. I can come and say Bobby the job is equal to, I would say, gardener. Gardener. I hope that's how you spell it. I don't think that's how you spell it. Let's just do that. And then when I say print Bobby dot job and run, you'll see no, and you'll say gardener. So this is a setter. This when it is a setter, right? Because you are setting the variable job for Bobby, the instance, to a gardener. So that's a setter. And now you will see how to make our own getters and setters. So it's very simple to make a getter for the name we actually have, but all we need to do is use the get. So I'll just say get. We use the get keyword like this, and with a getter, obviously you don't need this bracket. That's just the difference. They are all also methods, but you don't use these brackets with the getter. Now this is a getter that will return a string, get name, and then when we use this type of syntax with the dot notation, with this dot, we're actually calling the getter. So I can say Bobby dot, I can say print Bobby dot get name, right? Now it's the same as saying Bobby dot name, because it will just return the name Bobby. Now I'll just remove this, it's getting too much. And a setter, it's just, actually sorry, let's bring this back. It's a setter like this, right, where we set a variable, an instance variable, to something. It's quite different from how you make a setter, right? So with a getter, it's actually obviously not returning anything, right? So I say void, and then I will say set this with the set keyword, and then I'll say set, I'll call it set name, and then I would say string name, and then this dot name is called to name. So this means this is, as we said, they are just methods, so it returns nothing, and we use the set keyword, and this is just the name, set name, and this parameters name is actually, I'll just actually remove this, and I'll use the example so that I'll explain a bit better. So we'll say, what am I doing? Okay, Bobby dot, I can say set name, and then I'll just say equal for B with like 3 B's so that we can see the difference. So now this name that I said, the new name that I said, is what will be passed automatically by that to this parameter name, and then we're saying this instance, which refers to the Bobby instance, the name variable should be equal to the name we got from the parameter, which, because this is a setter, it automatically passes this, whatever we set it to, it automatically passes that in this bracket. So that's just a setter, right? So Hope that's not confusing. And now we have those, and I'll actually show you one more thing before we go to inheritance. If I say print, this is just a simple feature to make your life a bit easier when you are checking classes. So if I say print print Sarah, what do you think I will see? Right, I'm just saying print the instance, and I'll actually not see the variable information. I'll just see Sarah instance of person. I'll just see instance of person, because Sarah is an instance of person. Now I see instance of person, right? So when I just say print Sarah, I see instance of person. And inherently, whatever custom new object you make, like this instance person, as I said class person, actually automatically inherits. I know we haven't talked about it, we haven't made an example of inheritance, but we've talked about it. So it automatically inherits some methods. It automatically inherits some methods from a class called object, right? There's a class actually called object. Object, right? And actually I've never done this, but I'll try to see object. Actually, let's just see the docs. For now, I'll just clear these two lines because they are showing let's just see the docs of object. As you can see, we have a class object, right? The base class for all that object. So every object, right, including your custom objects, they inherit from this object class, and this object class defines some methods that you inherit. So one of the methods is called, I'll just remove this, one of the method you automatically inherit is called toString, void toString. It's called toString, and all it does is returns a string representation of the class. So as I said, print Sarah, it just says instance of person. But if we override this, if we define our own toString and we call it, it will actually sorry, this returns a string. So this toString, let me actually just show you. I'll just say curly braces for interpolation. I'll say this dot name. Oops, this goes outside. This dot name, right? And then I'll just copy this, and I will say this dot age, and then this dot job, right? This is just a string, right? I will say person, and I'll do that. So now, before, when I said print Sarah, it just says instance of person, and this is automatically inherited from the object class, right? But since we are now defining our own toString, and then whenever I say Sarah and then click on run, we will see what we defined because we just override the toString method. As you can see, we have what we have, Sarah 21 data analyst. And if I say print, let me bring this back, right? If I print Ahmad, I will just see this representation will be that for that instance. So toString is a method we inherit from the object class automatically, but we are changing it in our own class, so it's overriding. and there's this thing called add override, which is just an annotation that you use just for what do you call this in? It's just a best practice to use this override so that you can indicate that, hey, this is a method that we inherit from another class, but we are actually overriding it so that we present our own way of our own type of functionality for that method. So that's just one. And now we will actually look at inheritance. So we have a person class. I'll actually move this up a bit so that we get some space, and I'll leave that. I'll remove this. Now inheritance. So I will make another class. I'll just call it employee. Employee. And then to inherit from, obviously an employee is a person, so to inherit from the person, we'll just say extends person, and this is how you do inheritance in that, and that only supports single inheritance. So you cannot inherit from different several objects. You can only inherit from one object. In this case, the employee class is inheriting from the person, and that means we can do something like this. We can make the constructor, let's say employee, and then I'll just say var name, var age, var job, and then since it's an employee, obviously it has a pay, right? So as I said, this is a constructor and it's just an object, and these are just parameters that I made. And you might be saying I did not put this. That's because we don't actually have the instance variables right here, but we will have them when we pass this. I'll actually explain it, but first I will say colon, and then I will say super, right? That means this super refers to the super class, which is the person class, and then I'll just pass these parameters to the super, which I'll just make a space here. So I will just say name, because remember when we call this super, as I said, it just refers to the person class, and here when we make an instance, as you can see, we are passing the name, age, and job. So that's what I'm doing. I'm just calling the super to refer to the super class, and then I'll just pass the name parameter to be name. Now it's getting a bit confusing, I know. Job to be job, right? So what I'm doing here, let me just kind of clean it up a bit. Can I make this better? Format. Oh, nice. So what I'm doing here is just saying this is a constructor which will be automatically called when we make an instance of employee, and these are just variables that we pass to that constructor, and I'm saying call the super class of this class, and then pass the name into the name field. Just we are passing a name here, and then pass whatever name we get from that instance to the name of that super class, which is like this name, and then pass the age, whatever age we get, to this age, which is like this, and then pass the job. And the reason we are not passing pay is that if you look at the super class, we actually don't have a pay instance in there. So these instances will be made in the super class, right? and then we'll inherit them. And we can just say var pay, right? And then we'll just, this is an instance variable, and instead of just saying var pay here, we can just use this to refer to this instance of the employee, and then we are assigning the pay here. So to understand that a bit more, we will just say we'll make an instance of employee. So to save time, I will just change one person to an employee. So I'll just change, let's bring back Bobby, and let's give him a job. So let's make him an employee, and we're passing the name, age, job. Now he has a job. I'll just give him developer also, and then the pay, right? The pay, I will just say maybe 100. Is this 100? 100,000. That's the pay. So because this is an employee, we actually have a pay, right? This is what is being called the employee constructor, and we are passing those parameters, and all we are doing is calling the super and then passing those parameters in it so that we can have them as instance variables. Now just make a space. Now we have the employee. So this is inheritance, and as you can see, we actually did not define any method like the toString and this get name and set name. We have not defined them in our employee, but we actually inheriting them. So if I use Bobby, who is an employee, and I say let's print, and I say Bobby dot get name, right? If I use get name, this is something we have not defined in our employee class, but we inherit it from the person, right? Because Bobby, the employee, is a person. That's the relationship. And if I run, I will see the name Bobby, right? And this is a very powerful concept of inheritance, because you have a functionality that you don't have to actually rewrite, right? So you just inherit it, and you have it like for free, right? You actually don't have to write it to have it for the employee. And we can also do the set name, and we can also even inherit. If I say Bobby, for instance, I just say print Bobby. Now what do you think we'll see? Are we going to see just instance of employee, or are we going to see this representation? Right here it will just say person, and it will give us the name, the age, and then the job of Bobby. Well, I say we will see this representation because we will also inherit it. As you can see, Bobby 32 dev. But the issue is Bobby is an employee, right? And we want to show employee here. We don't want to show person, right? So that we will know that actually this is an instance of employee, not person. So the thing is, this brings us to another way to override things, but I'll do it differently. So we have toString in the person class, but we want to have a different way of a different type or different toString in our employee. So all we have to do is define it again to string, right? All we have to do is define it again, and I'll actually copy this, right? I'll just copy that to string, but we get an error because oh sorry, we return a string, right? So as you can see, this Bobby is actually an employee, right? And he has a job, a pay, but because we were using this, so we don't actually show the pay, right? Because in the person we don't have a pay instance variable. So when we define it again, we can say, let's just use that override. This is just something you use to indicate that, hey, this is coming from a superclass somewhere, and we are just overriding it to have a new functionality here. And I'll just say name age, and because this is an employee, we also have access to the pay of this employee. So now, actually, let's change this to employee. Now we have our own representation, string representation of an employee. And if I run this, this is not going to run because we've already overwritten it right here. So it's like an inheritance, and this is the super. It's like above the employee class. In any tree, you have the person above the employee, and then when you call a method on the employee, like get name, we actually search the employee first, and if we find that method in the employee, we will use that method. If we haven't found it in the employee, in the class, right, then we will go to the super class. If a super class is indeed in there, we'll just go to the super class, and we'll look for that representation. And then in here, we can actually we can see that representation of get name inside the super class. So what we have to do is say, now if I run this, the two-string representation, this two-string will be run, and then we'll see employee. We'll also see the pay. So let's run, and we see employee including the pay. So we are indeed running this method that is inside the instance, not this one like before, because we could not find it in here. Now with the employee, let's actually, I'll just leave spaces. Now with the employee, let's actually have another method, right? So I would say, I'll just call it string, and maybe we want a bonus, right? We want to give a bonus to the employee, I don't know, but we'll just say, I'll call it get pay with bonus, and this is just a method that will increase a bonus to the pay that we already have for the employee. So this pay, so I'll just say print Bobby, print Bobby, print Bobby. I'll just leave print Bobby, and then I'll say print get, sorry, Bobby dot get pay with bonus. I'll just pass the bonus of 10, maybe 5%, and hopefully we should see get pay with bonus. Oh, sorry, this is a type of employee, and we say string get paid with bonus. Bobby is a type of employee, but it's saying we haven't defined that. So let's see what's wrong. Get paid with bonus is in the class employee. Oh, sorry. Wow. How did I miss that? I said person, but it should be a type of employee. Sorry. Now it went away. So the type was the thing that restricting us. So now if I run, I should see the pay with an increased bonus of 5%. So the pay was 100,000. Is this 100,000? Yeah. So now it's 105,000. Yeah, that's 5%, right? So there's this thing. Let's just use this thing I want to show you. So what if we did not pass any bonus in here and just leave it like that? So because we are using the bonus we pass in, we're actually going to get an error. Let's try and run. Right, so we get an error because bonus, we did not pass the bonus and it's null. So obviously if you divide null divided by some whatever, you get an error. So I'll show you this operator, which is double question marks. Maybe you've seen this before, but this just means, hey, if bonus is null, then use default. We'll just use default bonus. I hope I defined that. Default bonus. How did I define it? I'll just copy default bonus. Now if we don't pass bonus, we just call get paid with bonus. We'll just see our bonus of 10%, which is 110,000. So that is just another method that I wanted to show you. But now I actually hit the format key. Now I'll just leave spaces so that it's not confusing. Now we have the employee, right? So let's do one more inheritance class, and this will be manager, which extends, well, we will extend the employee. Just trying to show you something. As you can see, we inherit the employee, which is a person. Now a manager is an employee, right? It inherits from employee, so that means it inherits all of this, including the pay variable, instance variable, and also get paid with bonus and default bonus. We inherit all of that. So I'll just make an instance very quick. Manager, right? For name, for. Now I just made the constructor and then just pass the values we get to the super class, which will make the instances for us. Now a manager, maybe we already know the pay for a manager, so I'll just say I'll give it a default value of maybe 1 million. I don't know. So 1 million, we have a manager, right? We just have a default pay of 1 million because it's a manager. We know that's what we pay our managers, So with the manager, we just print this manager, right? We will see that it's, well, we have no for the pay, and well, we don't have, we actually are not passing the pay here, sorry. Pay will be pay, so we forgot to pass that. So we have to pay, but it says employee again. So you can make this better by not hard coding this, by just doing something like this, right? Here you can say instead of saying employee, we can just say this dot runtime type, a representation of the runtime type of the object. So this will return the type of the object, which is going to be employee. So if I print this, because I'm calling it with the manager, and the runtime type is going to be manager, so we're not going to see this employee, but we're just going to see manager. So as you can see now, it's a bit dynamic, right? And well, actually it's getting too much here, so I hope you kind of get how to do inheritance. This is, I know this is all in one file, right? But hope you get the concept. You actually learn more by doing it yourself, by writing yourself, by coding these instances yourself. So what we're going to move on is mixins, right? How to add more functionality to our class, right? Without inheritance. So I'll see you in the next one. Now I know this is actually getting too much, but bear with me. We're going to write one more class. Well, it's a mixin actually. It's just a type of object that we use with classes to actually just extend our classes with some functionality, since we only have single inheritance, right? We can only inherit from employee. We cannot say inherit from multiple classes. Like I will write some other class here and then here. We can actually do that with that. It's just single inheritance. So a mixin gives us more functionalities. So whichever class we want to extend with those functionalities we wrote in the mixin, we just use it with that class. So I'm just gonna write a mixin, right? I'm just gonna say mixin. I'll call it employee access. Okay, employee access. Well, it is showing an error. Sorry, this is a small m, not a big capital one. So that's just that's how to make a mixin, and I'll show you how to use it. So before that, I will actually want to create an enum. So an enumeration, is just a type, employee status. I'll call it employee status, and then sorry, you don't do that. So there'll be on vacation, and then on assigned project. Oh my god, project, and then is idle. Oops, we don't put that actually. So this is just an enum. If you don't know what an enum is, it's just a type that you can store names like this ones. Very simple, and they are based on indices, right? This represents 0, 1, 2, and actually let's just see how to use it so that it will be easier. So I will say employee status. I'll call it status, and then I'll set it to employee status dot would set it to its idle. So that's how to use an enum. And now I'll just use a switch if I haven't showed this in the control statements. Well, that's because I want to show it here. So a switch statement, right? It's just it's simple. You write it like this: employee. This is actually a function first. Employee status function, and then in the function we're actually going to use the switch statement. So with a switch, if you have best practices, if you have actually about 5 if-else statements, you might want to stop the if-else statements and just use an enum use a switch statement instead of an if-else. So if instead of making 5-6 different if-else statements looking for a condition, just use the switch. It makes it more easier because well, this is how you write it. You say switch, of course, and then the constant you want to switch. So I want to switch status, right? And well, that is how to make a switch statement. And then you use the case, which is like a testing the condition right here. So if we're checking if employee, sorry, not if, why do I keep saying if? The case of employee, where am I? Okay, employee status dot is idle. So this status is what we are switching, and then we are saying if this status is the case, employee status dot is idle, then I'll just print employee is idle, and then you use a break. If you remember, this is how to break out of a loop, right? So yeah, a break. What is this error? Oh yeah, so because it's an enum, I actually have to make cases for all the different values of my enum. So let's move to the other case. Employee status dot on vacation. We're testing for that, and then we'll just print I'll just print employee is on vacation or vacation, and I'll break and I'll test for just gonna copy this. It's kind of getting tiring. So I would say what's other than on assigned project, and then I'll print employee I'll actually print currently assigned to a project, and then break. Now if status is idle, then we'll print this, and the reason we put break after every case is that we just want to run this case and then we break. If we don't have the break here, it's going to run this case, and then it will move to the next case, right? So the break is stopping it from here. And with the switch statement, if you know the switch statement, you know we have a default value like this. Actually it says case, wait, actually it doesn't say case, it says default. So this is a default if we don't match any of the cases we are trying to find. So we just have a default that will just fall here. So we'll say print employee status unknown. What happened to him? Unknown. Unknown. So what happened to him? And actually, okay. So break. Yeah. So this is a switch statement. If you have, you can use if else. In here you say if this status equal employee status that is idle, then print this else, check again, print this else, do this, print that else, do this. Or you can use a switch statement and just check for the condition. You just say the thing you want to check for, like this case we want to check status, and we are comparing status with is idle, on vacation, on assigned project. So this is very simple. So this is a very simple mixin actually, and how we can use this is also quite simple. So we just go to the class we want to use it. For instance, I'll go to the employee class, and then I'll say with, there is a keyword with. That means if you're going to use a mixin in a class, you use with and then the mixin name, which is this employee access. So I'll paste this here, and boom, we have that. And yeah, so to use it, simply come, I'll just come here and I would say void, I'm making a method employee status, which will use the employee status we defined here. This is also a function. So I would say actually, because we have the same names, I would actually like to, I'll just rename this, or you can say super.employee status. You know what? I'm just going to try to run it like that with the same name. So we'll just find an employee like Bobby, and then manager, we're going to use you but not now. And I'm going to say print, first I'm going to say print Bobby, and then I'll say print Bobby dot employee status. Now we're checking the state. Wait. Oh, sorry. So employee status, as you can see, it's where is it? It's void, right? And also here it's of the return type of void, so you can't really put it in a print. I'll remove the print. Go. And then I'll run. So if it works, because of the same names, but I hope it's actually going to work. If it works, we're going to see, because by default here, the where we set the status, we are setting it to is idle, and with our case of is idle, we're just saying employee is idle. So that's what we're going to print. So if I run, yep. So good time to actually explain what happened. So maximum call stack size exceeded, range error, maximum call stack size exceeded. So what this is saying is we actually caught in a loop where we keep calling the same function, like here, right? Because the names are actually the same. So when we call this employee status, we actually end up in here, and then this employee status actually is calling the same function, and then we keep going round and round. So we don't have it. That's why I said it's actually not going to run because of the names. So I can actually do super. Let's try super and run, and we see employee is idle. So it's working, right? Employee is idle. And simple thing, we can say Bobby dot status is equal to we actually have to use our employee status dot on vacation, and I'll copy this line, print, oh sorry, run this line. Now what we are doing here is just changing the status of this employee to on vacation, and then we will see it's idle because we are printing it right here before we change it to on vacation, and then we will see on vacation. So run, it's idle, is on vacation. So we see that. So this is just a mixin and how to just use it. As you can see, we actually did not raise the employee. We actually did not have to write all that functionality, all of this and this method, all of this we actually did not have to write it in our class. We just made a mixin, and then you use the with keyword, right, so that we can get access to those that method, the employee status method inside our mixin. And that's a mixin, and actually with this mixin you can use it in any class, right? You just have to say with and then the mixin, and then you get access to all those that functionality you define. So this is it for this part. We will move to abstract classes, and abstract classes are also a design principle. You'll see what I'm talking about, but they are actually quite easy. And I know maybe this might be very difficult for you if you it's for your first time in doing OOP. If not, I know you actually getting what I'm doing. So I hope you're enjoying this journey of learning that. So let's get to the next section. So let's look at abstract classes. So I'm just gonna remove everything. And then just have my little main. I'm doing this so that I can actually clear the console. I would say print hello. Yeah, run. I just want this to go. Wait, oh wow, forgetting the semicolon already. Hello. So abstract classes. Abstract classes are also a design method, as I told you, and what it means is that you can actually instantiate an abstract class. You can only define the abstract class and some methods in the abstract class. You don't actually have to implement those methods, and all classes that implements that abstract class will have to define all those methods that the abstract class defines. So what am I saying, right? Let's get started. So to make an abstract class in that, you actually have a keyword called abstract. Yep. And then you give the name. I would say automobile, and yeah, that's it. You have an abstract class, right? And it's not going to do anything, obviously. So sorry, wow, I need to say class. So this is how you do it. Actually, sorry, I forgot the class. So you say abstract class automobile, and then since it's an automobile, we just say void ignition void. Wow, what is this arrow? Yeah, okay. Void acceleration, void actually, you know what, I'm just gonna leave this too, because we're going to see something quite simple. So I will make a class. I'll say BMW, and then now to make use of the abstract class here, we just say implements the name of the abstract class mobile, and you'll see an error, yes, of course, because it says missing concrete implementation of automobile.acceleration, automobile.ignition. So we have to define those methods. So we'll have to give those implementations. So I'll just actually copy those two and then paste, and give the body as well as this one. And obviously you don't put semicolons after a function like this. So all the errors are gone, right? And I'll just say print print, yay. Actually, I'll just say print acceleration. So all an abstract class is if you have, actually I'll just run to get rid of this error. Nice. So all an abstract class is if you have the same functionality across your classes. You can define an abstract class to give all those methods that whatever class you make that implements that abstract class will have to define those methods. For example, we have BMW, right? I can also have a Mercedes, and then if I say implements, because obviously it's a car, it will implement this, implements automobile. We will have the error again, and now we have to write this also. We have to give the implementations of those functions from the automobile like this. So that's an abstract class. You have to, whenever you have the same functionalities across your classes like this, like this, we have a BMW, we have Mercedes, and obviously they all have ignition and acceleration. So you just have a abstract class, and we have those method declarations. As you can see, we actually not defining how those methods, what they do, right? We are defining it in our classes. So that's just a design pattern for abstract classes also. And yeah, so I think that's enough for abstract classes. We're going to see that when you're writing apps. So yeah, let's go to the next part, which is going to be generators. Now generators, I said that, right? So I'll just take this out, and what you need to know is that to make a generator function, you need two keywords, and in that, generator functions return an iterable. I'll just give this a type of int. And what is an iterable? Well, I will explain that. I'll just call this function my range, and then you say sync and then start this asterisk thing. This is how to make a generator function. And a generator is it just means you want to generate values, right? values sequentially, right? From, let's, for example, we want to generate values from 0 to a million, right? Like 1 million. And if we actually, for example, this function, right, this is what we're going to make, right? So back to the example, if you are generating numbers from like 0 to a million and we are calling that generator function, we actually don't want to, like at that instance where we call that generator function, we don't want to actually generate those values at once, right? From 0 to a million, right? We don't want to, because I mean it's gonna make our computer is gonna do a lot of work and it's gonna slow our program actually. So what we can do is with generators, right? So with generators you can actually step through, you can lazily load those numbers, right? So maybe you just requested to get a number up to 5 and then that's enough, and then later on in your code you can continue generating those numbers up to maybe a 50, and then you stop from there, and then later on somewhere you can load more numbers from that generator. So it's not actually making those numbers when you call it, rather whenever you want to get, you know, as much numbers from that generator you can actually get it. So let's write this simple function and we'll actually understand more. So this is a function myRange, and this is how you make it a generator. And this is the return value of the generator. It always returns an iterable of type an iterable. This is just an annotation because I'm going to return integers. So as you can see, an iterable is actually an abstract class. Sorry, where is that? So an iterable is actually an abstract class, right? And lists and actually sets and all those other things, the structures you can step through one after the other, they actually implement iterables, right? Now that we know abstract classes. So I'll just say, actually my range, I will take parameters, I'll say stat, and I'll give it a default value of 0, and then stop. I'll not give it a default value, and then I'll say while, you remember while loop, while stat is less than stop. And then in a generator you don't actually say return, rather you say yield. Wait, this is how to spell yield. Yield. So you say yield instead of return, and then you just yield what you want to yield, return what you want to return. So we say yield, and I will return stat, but I will say plus plus. So whenever we want to get a value, we'll get the value, and then when we call it again, we'll get the next value. So let me show you how to use this. So simply I can say, I'll just say my range is equal to, this is just a variable, and then I'll use my generator, right? My range, and then I will give it a stat. Actually, I'll not give it a stat because I'll just use this default value, and then I'll give it a stop of, I'll say 10, like this, and well, we get an error. Local variable my range can't be referenced before it is declared. Okay, so this is so I will actually just run. It says local variable my range can't declare my range because it was already used in the scope. Oh my god, what am I doing? It's naming. We are giving them the same names, so I'll just call this range. Why don't I call this range, and then range? All right, So when I run, I'll actually see my numbers from 0 to 10, but in brackets rather than something else. Oh, sorry. I will say print my range. Run. And I see the numbers from 0 to 9. And they are in brackets, right? So this is how you see an iterable represented. So what I want to show you next is that this is actually lazily loaded, because when I say I'll just say iterator. Now an iterator is a type, right? I'll just call it iterator, which you can get from an iterable. So my range dot iterator. Now as you can see, my range is actually an iterable, and I can say dot iterator, which returns a new iterator and allows iterating the elements of this iterable. So now we can actually manually step through the values of my range, which is an iterable, and I can just say if I dot move next. This move next actually returns true. Returns a boolean. If it returns true, that means there is a next value, and we can actually move to that, and hence we are safe to say I dot current. So you have to call dot move next to actually get a boolean. If it says true, that means current is available, and current is the current value that you are, right, when you are iterating. So for example, now I'm at 0, and then when I run this, I should just see 0. I see 0, and then when I call this again, right, I will see 1, 0 and 1, and again I'll see 0, 1, and then 2, right? So I'm manually stepping through my iterable, right? As you can see, it says it's a type that we can just step through it, but you have to call iterator first to be able to step, right? And there is something we can actually do. If I remember this this clearly, I don't remember it, but one thing I want to show you is that if you remember something like for var, I will just call it m in my range, right? You remember a for loop. So a for loop internally does this, what we just did, stepping through one after the other, but a for loop calls it will call my range.iterator to acquire an iterator internally, and then it will say move next. If move next returns true, then the for loop will actually get the current. It does that for us automatically, right? And we can just say print m. At this point, m is already gotten from the current of the iterator, my range. So if I run this, I'll see from 0 to 9. I will just comment this out, and then I'll run, and I see from 0 to 9 with the for loop. So this is what the for loop does internally, and it's quite cool. And this is actually sort of in the advanced section actually. So something else we can do, I'll just remove this, I'll just comment this out, and bring this back. And something cool is that we can actually do something like this j, and then we can get another iterator to from my iterable, my range. And these iterators can actually move at different paces, right? So for instance, with the I, I'm already at the third value, which is 2, right? But if I do this again, right? But I'm not going to do it for I will say J. Guess what? It's not going to go to 3 because J is an iterator of itself and it will start from 0. So actually I'll say from J, and then I'll just do this. Actually this is I'll do string interpolation, paste, and then I'll see 0 from J. J is now at 0, right? And you get the idea, right? J will now be 1. So these different iterators are moving at different pace, right? Because we call the iterator 3 times here and twice here, so they are all in different places in that iterator. And well, that's generators, right? And iterators, iterables, right? So generators and iterables. Now you know internally how a for loop works, this type of for loop. So now we're going to move to actually the last section, which is asynchronous programming. And that sounds really fun. If you are new to asynchronous programming, you're going to enjoy this one. And it might be difficult to grab at first, but yeah, it's really, really, really important to understand, because with mobile app development, you need those type of ways to write UI code, because you actually don't want to wait for something long to happen before a user can interact with your app. So all right, so we are going to talk about that support for asynchronous programming, and it's actually quite simple, but if you're new and you don't really know what it is, then asynchronous programming is just uh, a way to actually wait for a process that takes a long time to complete. So you wait for it, and then you continue, right? After it results, right? It brings back results, whether uh, whether an error or the result you're expecting or anything like that. For instance, you are getting data from somewhere else, right? From a server somewhere else, right? So you don't want to move on to the next line, and you without that result back from the server, because the next line is going to fail. You need that result to be able to run the next line, right? You are using it in the next line, so you can kind of wait for it to come back. So that's very basic. There's a lot more to say, but that's just a basic explanation. And with that, wait, I'm just gonna write this. So with that, when you make your asynchronous functions, right? For instance, I'm just gonna make a function actually to show you. I'll say future. I'll explain what that is. Future of type string. I will call it print, future print, and then this will just take a duration. Duration is also an object in that, which just specifies a time, right? I'll explain that also. And I will just say return future. I'll use the future class, and then dot delayed. This is just yeah, it creates a future that returns its competition after a delay. So I'm just creating a delay right here in the program, and then I'll just pass the duration I take, and then I'll say dot then. Don't worry, I'll explain all these lines, and then value, and then I'll return my message. So let's explain, right? So a future, in that, actually, let me just explain the future. So as it says here, an object representing a delayed computation. So what does that mean? There's this example actually that helped me grab futures when I was learning this one. So here it goes. Example, you are in a I don't know, a burger shop, where you want to order a burger in a restaurant or anything, wherever you go and order burgers, and you go and you order, then you receive a receipt, right? The burger is not yet ready, so you get a number or a receipt, right? So that receipt is actually indicating that, hey, you are going to get a burger as soon as it's ready, right? So you are holding the receipt, and then as soon as that burger is ready, you will get your burger, right? So that's just like a future. It's like the receipt you get, right? So it's not the burger, but it is like the receipt, because as soon as the burger is ready, then this feature is going to give you that burger. For, I hope you get that. So what we are doing here is just saying future, and then we're getting the delayed method on the future object class, and uh, the delayed method takes a duration, right, which we are just passing from the parameter of the function, and then the dot then right here is when the burger is ready, right? And then the dot then is a method that says, hey, the burger is ready, and this value right here in this anonymous function is the burger, or in this callback, you can call it a callback. Then you receive the burger. This value will be the burger that you ordered, and then yeah, you do what you want to do with it here, like you just eat it right here. So the future is like the receipt, and then you say dot then when the burger is ready, and you'll get it inside this anonymous function, and well, you do whatever you want to do with it here. And let's run this to kind of make it concrete. So I will say, first I will say print a, and then I will say where is my function? I'll say future. What's it? Okay, it's called future print, and then we take a duration object, right? So I'll pass duration. I'll make an instance duration, and then I'll say seconds, and then I'll just say 1, and now I'll pass the message, right, which will be, I'll say B, just to take this right, and then I'll say print C, and so what's gonna happen here, right? If I print A, I will run this program, and then I will see A, and then I will see C, right? And let me show you, after 1 second I will see B, because I'm creating a delay. Let me show you. Oh wait, I did not see B, sorry. Sorry, I should say print, because I'm actually not saying print anywhere here. But because this is a feature of type string, I can easily say, let's remove this. I can say dot then, and then value, value, and then what, print value. So because this is the future print returns a future, right? And then we said we can call the then method on that feature, because when it resolves, right, this is when it resolves, and the value is the message we are going to get from this function, right? So we'll have a delay of 1 second, and then B is going to be the value, because it's the message we are returning from the function. So let's run this again. I will see A, C, and after 1 second I see B. So this is just a future, right? And we are creating a delay. So this is not fun. What if you don't want to run this line, right, until this line resolves, because maybe you are using the return value from this line here, like you are actually getting a user's information from a server when you're trying to log in the user, and you don't want to proceed to the home page without that information. Then you can do, well, here we are actually, you can do something like this. With that you get support, asynchronous support. You get to say async. This is a keyword, async. This is where you put it in the function. This instance is the main function. I'm using async, and then what this allows me to do is say, hey, right here I will say await. So what this await does is say, it says await, right? So what it means is that await will stop the program, right? As soon as I print A, it will stop the program on this line until this line resolves, until this line returns, right? And then we will continue the program. So when I run, I will not see C, I will see A, and then I'll wait for 1 second, I will see B, and then C. So run, A, B, and C. As you can see, I'll run that again, A, and then we wait for 1 second, and then we see C. So yeah, this is how it happens. This is very simple example of that support for asynchronous programming, like this, right? Async, don't forget this. If you want to use await, you have to make the function asynchronous, and then you call await on the line you want to wait for. And this is very simple, basic, and hope you understand it. We will be using this a lot actually in app development when you get started. So yeah, stay tuned for that. And the next thing, the last section, maybe I said that once, but this is going to be the last section, and it's going to be quite important. And at first, if you don't know what we're going to talk about, it's going to be very difficult. And so this section is going to be our streams, and very important structures you need to understand with that. So I'll see you in the next section. So now streams. Well, we just looked at futures, and futures, as we said, they just represent a computation, right? That kind of takes some time to resolve or return, right? So streams are just sequential data. It represents sequential data, like futures, right? So with a stream, let's look at it as a as a pipe of sort that you get data through, right? Data comes through, and that data that comes through that pipe is actually not available at the time, right? So it's for instance, you actually just listen to that data stream, that pipe, and whenever there is new data coming through, then you will get it, right? Whenever there is new data coming through, you'll just be getting all the data that's coming through, but you are just listening for data to come through. So that's just basic explanation of streams, right? So we'll look at a very simple example, and we'll explain more in the example. So what I'm going to do is obviously my main, but I'm going to create a class of drive through, call it drive through like this, and in here the drive through is for instance, in a real example, you order, right, and then you drive to the place you'll receive the order, right, and then you move on, right? So the place you put your order, right, that little mic, right, so that will be like where you add data to the stream, right? So you can add data to the one end of the stream, which is called which is the sink, and then where you receive the data, that is where you listen, right? I will show you right now actually. So with that, you actually define a stream controller. For now, I'm just going to give it a type of string, so we know, hey, we are passing string through this stream controller. So the stream controller is a convenient method, convenient class in that creates a stream internally, right, and then controls that stream that it creates. So it gives us methods that are very simple, like add data through the stream, and also listen to data that's coming out of that stream. So I can just say I'll call this controller, right? I'll make the instance stream controller. I'll just give it a string, and yeah, so here I just make the instance. I'm getting a lot of errors. Oh, and one more thing, to use stream controllers, you actually have to import that async. That is where you get the stream controllers, right? And as you can see, a controller with this stream it controls. So this creates a stream for us, and then it gives us access to that stream when we do something like this stream. I will make a getter, and then I'll call that getter since this is a drive-through, like just where you talk and where you place your actual order before you drive to where you collect that order, right? So where you make the order, the mic, this is the mic, we are making the mic right here. So I'll call it I'll say on new order, I'll call it on new order, and then as I told you, the stream controller gives us access to the stream it created for us, and the stream, forget this, the stream get on new order, this is a getter. So this is the stream that the stream controller actually controls, right? So this is like this is the stream which we can actually listen. This is like the pipe, right, from where you make your order at the mic to where you accept that order. So this is what represents that, a stream. And I will make a method. I'll call it I'll call it I'll say get new order. I'll call it get new order. And this is a method that just actually listens, right? This is like the kitchen, right? Like the kitchen that actually listens to your order from the mic. So we'll say on new order, right? The stream dot listen, right? Dot listen, and then when we are listening, we actually get whatever order that's sent through the mic, which is the beginning of the stream. Whenever whatever order that's sent through, right, we will receive it right here inside this little bracket. So I'll say order, right? And then what I will do with that order, for now I'll say print order. I'll say print order, right? So this is the stream, right, from the mic up to the kitchen, up to where you collect your orders. This represents that, like a long process, right? Like the pipe the communications go through. So you are listening, and then this is like when we call the listen, it's like the kitchen, right, where we hear all the orders. So whenever an order is coming through, this is where we receive it. And then right now we're just printing that order, and then void. I'll make another method. I'll say new order, how you actually make the order. So this method will represent like the mic, the actual mic you talk to, right? So I would say on new order, because this is the stream, right? And with the stream we have the beginning, so this is like the beginning, which is like the mic for the drive-through. And we'll say dot add. This is a method on the stream which lets us add, right? So for add a value through the stream. So from the mic we are now saying fries and some other things, or whatever you want to order, and then we'll add. Actually, I'll take order in here. I'll just give it a type of string, and then I'll say order, and we are adding, and it's saying the method add isn't defined for the type stream. So we have problem, so sorry, the stream, we actually don't say that on the stream. We use the controller, since we are using a stream controller, and the controller controls the stream. So the add method is actually on the controller, right? Dot add, and then the order. So if we click on the add, we see sends a data event, right? And it says listeners receive this event in a later microtask. So this is the listener, and when we send the event using this method, we are already subscribed being to a listener on the stream, right? And then when we send the event, we receive the event right here. So this is, like I said, the kitchen of for drive-through. This is like the actual mic you talk to order. And well, for now we actually have that. So I'll just make another class to make this more fun. I'll say kitchen. I'll call it kitchen, and all I'm going to do here is just say void. Actually, this is a chance to show you a class method, which for you've been seeing instance methods like this one, which you can only call with an instance of your class. But now if we say static, right, and then I'll just give it a return type of void, and I will call it prepare order, right, which takes the order to prepare, and then I'll just say print I'll say preparing order, and maybe a dot dot dot, and maybe a smiley face, and print order, and I'll put the order in these brackets. I'll say order prepared, or place your order, thank you for coming, all of that. So this is just a convenient method, and I'm sorry, this is a class method, right? You declare it with static, and what that means is that we don't actually even need the instance, right, to call this. I'll show you what that means. So now we're just going to use our drive through first. So I'll just make an instance. First I'll give some space. I'll make an instance of drive through, I'll call it drive through also, drive through. This is an instance of drive through like this, and next thing I can say drive through dot, we have, we shouldn't make these guys actually private, sorry. So with an underscore, this means this method is actually private, and we should not do that, right? That means we cannot access it outside this class's instance. But for now I'll just do this, and I would say what you should expect is that I would say drive through dot new order. So I'm making a new order, like I'm talking to the mic, right? And then I'll pass the order. I'll just say fries drive through dot, what's this method, new order, undefined name drive through. Oh, we made a mistake here with the T, drive through dot new order. So what we should expect is I say new order, and then I'm adding that order through the stream, right, to the stream using the controller, of course, and then I'm listening right here, right? So I should get the order, and then I will print the order. So if I actually run this, I see nothing. Now why did I not see anything? Because we are forgetting this get new order, which means this means like we are open, right? If the drive-through is closed, you can talk as much as you want, no one's gonna get you your order or anything. So we actually did not start listening, we did not subscribe to that stream, like we are not open, so we need to call drive through dot what's the method, get new order, which then calls the listener. So we are subscribing to the stream, right? We are open, right? You can now talk to the mic and we can hear you because we are there. So now when I run, I should see fries. So I'm not really using this one now, so let's just use it. So I'll just create an instance of kitchen. So I'll just call it kitchen. Let's make an instance. You know what? We actually don't need an instance because this is just a static class method. So what we can do is, after we are listening, and then whenever a new order is in, we can just get that order, and then we can use our static method, which is kitchen dot prepare order, and then I'll just pass that order, right? So as you can see, we just call the class name and then we call prepared order. So what the static does is that we don't need to put this brackets to make it an instance. As you can see, it's showing an error because it's a static method, and we can't access it through the instance. We can just do this without an instance. So if I run, this should work with the print right here. So run, preparing order fries. Now this is like very simple. Let's just try to simulate a real one, right? So maybe you place an order and then it takes, I don't know, like 5-10 seconds, however long it takes you to go to the little window you actually collect your order, right? So since we know about features, and making delays, I can just make a delay right here, right? Feature that delay, it takes a duration, I'll say seconds. This is just trying to simulate one. I'll say 4 seconds, and this, so you should expect this to work. But as you know, if you want to stop our program until a feature resolves, right, we declare the method as asynchronous, and then we await on that method to finish before we continue our program. So now when I make a new order, I should see preparing order, and then we delay for like 4 seconds, like you're driving to the actual place you take your order, and then we print, right? Very simple. So preparing order, we wait, and then order fries prepared. So I will just make some more orders like this. Make another one. I would say wings, coke, blah blah blah. I'll just leave it like that. I would say burgers, burger, and now these are 3 different orders, right? As you can see, we just call listen once, so we are listening on the stream, and then these are just orders coming in, and the kitchen is taking it, and each order will wait because we are doing this. Well, it just received all the orders and we are preparing them, and we prepared all the orders, right? So you can, I don't know, it's just a simulation, but the main idea here is streams, right? They are just sequences of data, sequential data. You are just waiting, right? You subscribe, you listen on the stream, and then whenever there's new data coming through, you actually get that data, right? As you can see here, we just added a lot of data, right, with the add. So a stream controller as well is a convenient class that creates a stream and then gives us methods that to actually use that stream. So that streams, and there's a lot more with streams because you can send errors through streams. You can listen on different streams at the same time, right? Like right here, we are just listening to one stream, and we can only do that with this type of stream. But there is a stream called .broadcast, which actually, I'll just make it just to show you the documentation. Broadcast stream, as you can see, throws an arrow. as you can see, a controller where stream can be listened to more than once. So this is the broadcast stream. You can have like maybe different types of kitchens, and then all the different types of kitchens have their own listen, right? Maybe a burger chef is listening on one stream, and then a chef that fries your fries, and then different people, different places are listening on that stream, right? And they are getting their correct data coming through. So there's a lot more to streams, and we'll see that a lot when we are making a full-blown app, which we'll be doing. And stay tuned for that. So well, this is actually the last section, and this is a very basic primer intro to that, and I hope you learned something new. And if you did, make sure to subscribe, and we'll be making a lot. We'll be making full UIs, full apps. We'll be looking at widgets, very deep dive into those, and animations, and packages also that on the Flutter, from the Flutter community, to make our development easy. So I'll be looking at all of that, and make sure you do subscribe. Videos will be coming out, all the time, every week. So stay tuned. All right, take care.